Hi everyone, welcome to this combined presentation and I would say BOF session about TPM in T. So I'm going to start with a little bit like an overview of what a TPM is, just to get people a little bit started and talk a little bit about the different features that you usually use in a TPM. And then I'm going to discuss a little bit about the firmware TPM itself and something that we have tried out and so on. And then the other second half of this, I would like to have some kind of open discussion with some questions about use cases and why do we need to do this and so on. So the motivation for the talk, people, I can't see the guy who was kind of, where is Francois? The Ledge team, they were the one who was kind of driving this and asked about, can we run a TPM in a T environment? So personally, I've known about TPM quite a while, but I've never really used them. So I had to do my homework also to actually read up and understand a little bit more about it. And then I also had to explore existing implementations out there and see have anyone already done something that we can use and so on. And of course, as you can imagine now, since we're running something in a software-based environment instead of a chip, you have trade-offs and so on. And as I said, use case study, who should use this and where and why and so on. And if we get some consensus here saying that this is something that seems to be good to have, then it might be that we actually propose this in the future for TSC and try to do something in Linaro with it. So TPM, how many, we have Bill here, he's an expert on TPM, I know that. But if there's anyone else here, Stuart, if I'm saying something totally wrong, please just shout out. And also, by the way, we have microphones. Feel free to interrupt and ask questions while I'm talking. So TPM, I mean, you have probably seen it. If you have a motherboard, you usually see something. If it's not solder on, you have it like a slot where you can put a standalone TPM. Or as we did this 96 boards a couple of years ago, we put the TPM here. Or you have it soldered directly on the PCB. The TPM itself is a passive device. It's not really that the TPM can force you to stop booting or something if you don't have the correct signatures and so on. So there's always someone calling the TPM and making a decision based on the reply. I've listed a couple of use cases here. I will go through some of them a little bit more in detail. So I should maybe mention some which I don't going to talk about. Audit of log trail, I know that is one of the things that the Ledge team are interested in. How can you prevent that someone is tampering with a log file, for example?
The rollback is another really interesting use case, rollback protection, because at some point you want to get to a firmware version that you can't allow users to downgrade to potentially buggy or unsecure firmware revisions.
Exactly. And I mean, regardless what kind of hardware you've been working with in the past when it comes to security, you can see a lot of these things are overlapping. You can see things here from T environment, HSMs and whatever. DAA, that's a big complicated beast, and if someone knows how that works, please tell me, because I don't. That's a lot of complicated maths and so on. So TPM has been around for quite a while, so most laptops, I guess even today, have a TPM 1.2. But we are starting to see more and more 2.0 devices. And 1.2 it was a little bit limited. I mean, you could only use RSA 2048 keys, and it was using SHA-1. You couldn't really change anything else. And since it's based on SHA-1, it's been said that you can't really, I mean, it's not considered secure anymore, so you shouldn't use it. So that's why I put here it's unusable. It's of course not unusable, but you will not really put a TPM 1.2 device in new hardware today. A difference otherwise with key handling is that on a 1.2 you generate like an endorsement key, storage root key and so on, while you in TPM 2.0 instead use a random seed and you have some templates where you can generate different keys and so on. So the root of trust is not really a key in TPM 2.0. The root of trust is a random seed. TPM 2.0 also enables many more alternatives when it comes to cryptographic operations. So you have all the, SHA-256 and elliptic curves and so on also. So when it comes to the key generation, as I said, you're using this seed. So this is the TPM itself. On the different hierarchies, there are 4 different hierarchies that you can use, depending on if you're a user or a platform vendor and so on. But you take the seed and you take the template and you run it through a key derivation function, and you get a primary key. And with that primary key, you can then create kind of tree structure of keys, which you can export, since they will be, the private key on the exported keys will basically be wrapped by the public key. So, and as we will see later also, this is kind of good in that sense that there's limited storage in a TPM device. And I think most people who have read about TPM have heard about these PCRs, so platform configuration registers. There is a set of them, and different regions are supposed to be used by different use cases. So maybe PCR 0 to 5 is used by firmware, and 20 to 24 could be used by the operating system and so on. But what it is basically a register holding a hash value. So when you boot up, we'll see that in a coming slide here, you basically make a hash calculation, and then you give that to the TPM. And the TPM just stores it. And then you can use it later on when you want to verify the state of a system and so on. I will come to that in some slides. So, but it's just a running hash basically. So if you see normally how we do, for example, in crypto implementation, you have hash init, update, and final. You can see this as the update function, update, update, update. And the way to read out the PCR values, that's with something that they call quote in the TCG specification. So you basically sign the PCR values. Not sure, it's maybe a little bit too small, but this is a picture showing what is called a measured boot. It's not really, the normal secure boot that we're doing, but it kind of reminds of it. So here I've put together an example where, for example, have the ROM code who verifies the first bootloader, normal verification with signatures or whatever. Then the firmware can measure itself and send the PCR value to the TPM. So it could be, like I said here, PCR 0. And then the firmware measure or take the hash of the next bootloader that it's going to load and send that PCR value to the TPM. And that's how it goes on for each and every boot stage. So when you've done that, then you can start doing this remote attestation feature here. So you use that when you are you have a need to verify the state of a system that you are talking to remotely. So how can you ensure that a device hasn't been tampered? It should have been booted up in a certain state. And the way that it works is based on this PCR. Since the hash computation is, you can't really change it. So if you change the order of boot binaries and so on, you will get a different hash value. So you know that if the signature of the quote is correct and the hash value is what you expect, then you can know that the system is in the state that you expect. And yeah, as I've written, you can do it one time, and you can do it in time-based if there is some need to check it all the time and so on. Sealed keys. This is a pretty cool feature and quite powerful also. With sealed keys and data, you can use the TPM to lock down things that is only possible to use when the system is in a certain state. So you can think, for example, in say in U-boot we want to unlock a certain key or something, then you could use, based on the PCRs you can boot up, and when the PCRs have a certain value, then it will unlock a key. You can use that. And then if you continue booting, you will get another PCR value and it will be locked again. And in TPM 1.2, this was hard to use, since there was no really easy way to upgrade things and so on when you did like this. And that was one of the things that they addressed in TPM 2.0. So now there is a way to more easy, unseal and sign another value that will be expected in the future also. But there are some things that I still haven't really figured out how to deal with. Like I said here, what if a hard drive gets unrecoverable bits? I'm not sure if any one of you have more insights into it, but I guess there must be some way to take things like that into account also. And yeah, Microsoft, they are using this. So if you have BitLocker enabled on a Windows device, this is how it works. They seal the full disk encryption key and unlock it at a certain state. When you communicate with the TPM, you of course also need to authenticate yourself in some way. I've listed a couple of things here. So you can use normal passwords. Nothing strange with that. You can use HMACs, so you have some kind of shared key between the caller and the TPM itself. I guess that's considered as a little bit more secure. Otherwise, you can use what is called policies. And I've listed a couple of examples of policies here. You can say that you can only use some feature or unlock some key or do something if you have certain values in PCR, a password, a sequence of TPM commands, and so on. And it's not that you can only use one of them. You can combine them, mix them together in different ways. So this can become pretty complex, I would say. And the trail one I've listed here is that is something that you use when you're kind of generating these new PCR values if you're doing some update or something. No one interrupted so far, so probably I've said something correct. Resource manager. So a TPM is a bit limited. Only one entity can talk to it at a time. That means that there needs to be something sitting in between who communicate with the T and yeah. So you have some kind of control who is handling all the communication and so on. And in the TCG specification, this is called resource manager. It used to be a user space component in Linux, but in kernel 4.12 it's been merged, so it's officially in Linux. But this is important to know. You have a limited amount of users that can use it, which also makes this a little bit complicated later on. If you have the full system up and running, we have the same issues in Opti today, for example, that someone owns a device. If we're using EMC, for example, we have to rely on Linux kernel, since Linux kernel is the one who owns the device. It's the same here, basically. This is the picture of the TCG software stack. Most of the things here is actually running in user space in Linux. And there's a lot of layers. Depending on what you're intending to do, you use the different layers. If you embed a device low level, you might go on the lower level layers instead. But then you lose some of the features that can help you, like I said, session handling or some crypt operations and so on. So you get more and more features the higher up you go in the stack. So it should be, in theory, it should be easier to use it from the top, so to say. But this is a quite big thing and pretty complicated also, I would say. So, and it seems to grow for each release. So that's the primer. Any questions so far? Crystal clear. So let's jump into the firmware TPM. So my definition here is that a firmware TPM is when you have something running in a secure environment that acts like a TPM. It should work with existing tools like the TCG stack. From user space point of view, you shouldn't really see any difference, and it should in general be as compatible as possible. So Microsoft have done a firmware TPM implementation. It's based on the 2.0 TCG specification. The specification is written today as it's both text and you also have source code. So you can actually compile it if you just copy-paste enough with stuff. But the good thing is that this is on GitHub and everything. So for me, it was pretty easy. I mean, you can basically just go to the Microsoft page and follow the instruction, and it will compile this for you. The thing is that they've done this for both Intel and ARM. So you have a little bit of mix with files and so on. And I had some issues since they have copied files. But yeah, I figured that out. So the funny thing here, or the good thing here, is that according to Microsoft, they're actually shipping this in lots of devices today. And there was a talk at Usenix a couple of years ago who goes a little bit more into the details. But in general, it's an implementation supporting x86, supporting ARM, and for ARM they used Opti. And last week, Thursday evening, something I managed to get a working setup. I've done things a little bit different compared to the Microsoft instructions. They don't really tell how to deploy things and so on. And since I'm used working with our Opti full developer setups, I wanted to do it more or less the same. So people who are aware of how we are using our developer setup will feel that this is pretty easy. So you basically set up the prerequisites that we have, you repo, clone, tree, and so on, get the tool chains and build everything. And when you have that and boot up QEMU, you get two consoles, and in the console acting as normal world Linux, you can run these commands now. And you have the instructions there if you want to try it out. I haven't had time to really dig into the details, I mean, to see where the bottlenecks are and what's actually going on under the hood and so on. But it seems to work. It's a little bit slow in some cases, I've noticed, when you're loading the driver and so on. And one thing that they are using is Wolf SSL here, and that's a GPL v2 crypto library. So if we would like to use it officially in Opti, for example, we would need to replace that with something else. So when I looked into this, I stumbled upon a couple of different things, I mean, pros and cons. So when it comes to the crypto operations, the TPM, it's like the tuk-tuk, and the T is like the Ferrari in this case. So it's slow. So I think that's one of the good things with running it in the T, for example. If you do RSA key generation verification and so on, it's pretty fast. So in general, a TPM is slow. So that's one thing that should be considered. But then we also have like RNGs. A TPM uses an internal TRNG, which I was a bit surprised. Apparently there is no real FIPS requirement or something on the TRNG in a TPM. It's a little bit up to the TPM vendor to come up with a good TRNG. In a T we can use that also, but I mean in our implementations today we are basically using software implementations, but the one who deploy a T environment, they should have a TRNG. Then we have the storage. As I said, the TPM has, I think it's like 64 or 128K or something that you can use for storage. So it's a bit limited. Compare that to a T where we have a couple of different alternatives. We can use regular flash, RPMB, and so on. But you also have to pay attention here about security, for example. I mean, you can't really argue saying that storing something in a regular flash is secure as storing it directly in the TPM itself. I mean, anyone can desolder the flash or corrupt it or whatever. So that's something you also need to consider. Secure clock is another thing. I mean, TPM has their own internal counters. In T, we have different ways that we can use. I mean, we can use the clock from non-secure side, but for secure operations, you should use the secure clock instead. When it comes to the seeds, yeah, I don't think I said that, but the seeds, when you generate the seeds initially, they will never leave the TPM. You can't get them out of the TPM. So they're only used, as I said, for the key derivation and so on. If you're going to use seeds in a trust execution environment, well, there are a couple of different ways you can do it. If you read and listen to this Usenix talk from Microsoft, they use the fuses, but there are some challenges also. If the seed for some reason should leak out, well, then you're basically done. You can't change it since it's burned fuses. Flash, you can't use it. As I said, I mean, you can't store something that you shouldn't be able to tamper with it. RPMB might be something that you could use, but it depends on, yeah. Now we're getting a little bit into implementation details. I mean, today we can use RPMB from U-boot, and we can of course use it when the system is fully up and running. But before that, it's a little bit tricky. And the final thing I was thinking about was side channel attacks. I mean, I suppose that the TPMs are quite well tested. I mean, they probably have this as different laboratories, and they have been trying it out and so on. And with a T implementation, we have the full ARM system with, well, who knows where you can attack. I mean, there's all sorts of ways that you can do side channel attacks. So my takeaway here is that, I mean, you can get the same kind of behavior when it comes to features as a regular TPM. As a user in user space doing the commands, you will get the same kind of replies as you would get from a real TPM. So that's a good thing. Security, there are differences, and I think it's important to let people who want to use the firmware TPM to know about the trade-offs, because it could be that there are use cases where this is actually not secure enough. And as I said, performance-wise, there is also difference. I'm not sure if it's that super important. I mean, I don't think that you use a TPM very frequently usually, but there could be use cases where it's important. So that's the firmware TPM part. Any questions? I'll give you a second.
I guess, can you say a little bit about like what was motivating the interest in TPMs from like Linaro point of view? I mean, I'm aware of a little bit of it, but just curious about your.
Maybe Elias can say something about it.
Sorry, can you repeat the question? Because
Yeah, what was motivating the interest in TPMs from the point of view of Linaro and like a trust zone based?
Right. I'm Elias. I'm part of LEDS. It's Linaro's Edge and Fog networking department. So we do have an interest on securing hardware devices from physical attacks. So, for example, the remote boot attestation that Joakim mentioned, this is really important to make sure that the remote device that you don't have access to hasn't been tampered with. One of those use cases is this. The second use case is that we can use the TPM for anti-rollback protection. And since we're trying to do a reference platform to figure out that to have a huge case that this is doable, having a software TPM is really easy for us. So we can use the software TPM as part of the reference platform. We can show that this is doable. We can pack it as a distribution, and if the hardware has a hardware TPM, you may as well use that because it's probably going to be more secure.
So I guess we're kind of touching this already, why we want to run a TPM in a T.
I guess one follow-up question. So when with the rollback, are you talking about someone trying to roll back the firmware of the device?
Yes. rollback to happen. For example, you might not want the rollback to happen because it's your firmware, it's your device. The second use case is that you might have a device that you've actually found a software bug that causes a remote, allows remote attacks or anything like that. So you want to prevent the users from actually being able to downgrade to a vulnerable version.
So yeah. So I don't know. I mean, I'm happy to hear what you are saying here. I mean, I've just, after chatting to people and looking into things, I've listed some things here. I mean, I guess some people are interested in saving. I mean, they don't want to put a TPM on the device to save. I think it's $1 per TPM or something. You also have, I mean, PCB area could be quite valuable also in some cases. So you could save a few millimeters, I guess.
Operations only the speed that you get from the software implementation is going to be huge compared to the I2C interface that the normal TPM does.
Yeah. And I could also think about, I mean, reusing existing APIs. If you have had a device who used TPM, and then you change the design or hardware in some way, and you don't have it anymore, but you still want to use the same kind of user space stack that you've been using. That, I guess that's one of the use cases also. And typically mobile devices, they usually don't have any TPM. So in case someone wants to do something like this, well, then this might be something. But I also want to emphasize that I don't think people blindly should just look at this saying, oh, we need to use a TPM to be able to do remote attestation. You could as well do the same things in just using T interfaces, and even, like I mentioned here, OTRP, they have touched remote attestation also. So I mean, I really would like to see that there is a good, solid use case where you actually need this. Otherwise, you can probably strip away quite a bit of code, the TSS stack and so on, and just use the T itself. So I don't know what you're saying about it.
Is the FTPM implemented as a trusted application in Opti or?
Yes, yes. So the FTPM implementation from Microsoft, they have, it's a normal trust application as we're usually running in Opti.
Right.
So.
So during the, so if you want to get the PCR values of bootloader stages which are running prior to Opti, yeah, okay. Right.
You're ahead, Sobi.
Yeah.
But we can, yeah, that's one of the challenges that we have, of course. I mean, what we're trying to do here now is something running in BL32, Opti in this case. So, like you said, what should we do before that? Yeah. Should we kind of cache the PCR values in some way, or that's an unsolved problem? I mean, we need to figure that out if we want to do it. I mean, after that, I guess it's easier, but still there needs to be some kind of interfaces implemented here to be able to support it from different places in firmware and so on. Having that said, I mean, even if you would have a, well, if you would have a real TPM, it's there, but you would still need to implement it. And we don't have anything in trusted firmware today, for example, who supports this.
One other comment on the use cases. I guess one other similar scenario is there's virtual TPMs. Like if you have a system with virtual machines and the virtual machines are running a TSS stack and need a virtual TPM. And the way, I guess, the way you can do it, like say with KVM, is there's a user space process that can have the TPM functionality in it. There's a project called SWTPM. But one more secure way of doing it, I mean, that's just running in user space. You could have user space FTPM, and you could also run this in trust zone. So another case for running a TPM in a TEE would be, instead of, and that wouldn't be the system TPM, but it would be, you know, supporting a virtual machine that needs to, you know, talk to when. So.
Yeah, you're right. I mean, that's, if people have seen about this VTPM implementation, that's basically what you're saying, Stuart. I mean, they have different virtual machines. One of them is acting like a DOM serial, you can say, who is kind of the one who owns the device itself, and the other virtual machines communicate with this first virtual machine. So, and that's, of course, one thing you can do also.
I have one question. I saw you said there's a lot of spec in for TE, of course, but I didn't see the spec for the TPM. For my question is that sometimes I don't know what which use case should locate in the TE or TPM. Do you have some guides for that?
If we jump back all the way to the beginning
Uh,
here.
Yeah, because recently we keep thinking about to design a TPM, but I have met this problem because
Yeah, yeah. I mean, if you just have a look at these use cases here, I mean, measured boot, that's typically a TPM thing, but I would say that there's nothing preventing you from doing the same in a T. I mean, it's just storing a hash and update it and so on, and that's not a big deal as such. Key generation, key store, signature generation, that's normal crypto stuff you do in any solution. It's not only a TPM. So HSM, whatever. Same with remote at station. I mean, if you have the measured boot, then you can do the remote at station also. So I actually think that everything here is something that you should just as well be able to do in a trust execution environment directly.
we are thinking about the last one, the device identification device. Yes.
Yeah.
That's.
But that's based on the, I mean, basically on the seed that you're using and so on, that is known. So you can use that as an identifier for that device.
Yes.
Yeah.
That's critical.
Yeah.
Another question. You have in your session you just talk about the firmware of the TPM, right?
Yeah.
I just wondering that if we have a isolated hardware processor to for the TPM, your firmware is compatible for the or I want to know if the TPM firmware can run as isolated processor. We are thinking about to design as a processor for the TPM.
So a separate.
Yeah, separate
CPU.
Yes.
Yeah. Well, I think that's. You could probably add a firmware TPM there also. It's just figuring out how the communication protocol should be. I mean, it's the same now when we're running here in a T. I mean, you need to pass the information from user space down to whatever device you're using in some way. So in our case, it's the normal way with SMCs and so on.
Do you have any solution for or such solution for the TPM? I just want to know if you, as you know, in the Google Pixel 3, they have isolated Titan processor. You know, we have learned that just for the device identification is running in the Titan processor. So I don't know if your firmware is just designed about such a consideration.
Yeah, it's a little bit hard for me to say about how that works, but I mean, I think I can't really see why you shouldn't be able to use it in another device as long as you have a way to communicate with the device. I mean, you have to serialize the commands coming from user space in some way, and then you need to parse it on the other end. So how you do that, well, I guess that's doable.
Okay, thank you.
If you go on the Microsoft project, there is some code on SN32F4 family. So they use SN32 as a TPM processor, and there is some examples. And you can connect over SPI or SPI, and it's the same project compiled in another way.
Okay, thank you. I didn't see your slide on the website where you upload the PPT to the website of the Linaro. Okay.
This one?
No, all the slides.
All the slides, yeah. You will go to connect.linaro.org and then you will find the links. I think they should already be there actually. So. So we've already touched this. I mean, we know that the Ledge team, they're interested in this. I'm not sure about other people here. And I mean, I'm not looking for a company name. I'm more, I mean, of course that's also welcome, but I mean, if you know about use cases where this could be useful, or there are SIGs that have a need for something like this, then I would be interested in knowing about it. Because we are at the verge right now where we are going to basically need to make a decision whether we should do this now, later, or just drop it. So that's why I'm looking for feedback in general. Yeah. I know you are definitely interested. So.
I'll even volunteer to help.
Yeah. And I know some more who are probably interested in this. So,
I'm pretty sure that the Ajax is a TP.
which one?
Ajax.
Ajax.
Dell.
Yeah. So, I mean, if we find out all the use cases and so on, the next step I would say is to actually go into the different components there where we want to use this, like eventually trusted firmware, and figure out how to deal with things that, like we said, before the T is loaded and so on. There could be other components also, I mean, U-boot, UEFI, and other things that we're using. And I also think that even though Microsoft say they're using this, I think at least we would need to look into it, how to optimize it for our setup, so to say. And as I said, replace Wolf SSL and a few other things. And I also think like the kernel driver that I tried, that probably need to be reworked a little bit also. I had some issues when I was trying to use it the first time. Yeah.
Okay. Me first, thank you. Okay. In the, I don't know which slide you said the TPM only include three situations or three cases. Three storage. Why do you design more than three cases of storage? What do you think?
Okay, so you mean here?
No. Three situation. I mean, something like that. Resource managers.
Yeah. This one.
Uh,
Yeah, that's a limitation of the TPM itself. I mean, it's
just a limitation of the hardware.
it's a limitation of real physical TPM. I mean, a real discrete TPM. So,
Okay, thank you. I because I don't know. I want to know if it is for the security of the TPM. In my consideration, if there's a lot of in this case, or a lot of things put in the TPM, maybe the TPM contain too many things. I don't know if maybe it's easy to attack. It's not security in my consideration.
yeah, I mean, I would say that TPM suffer from the same things that T environments suffer from. That is, you're doing secure operation from a non-secure location. So,
Okay.
I mean,
I got the idea.
one thing is, of course, as usual, the denial of service. That's something that there is no real good solution for that.
Okay.
And you also need to ensure that the information that you're sending to the TPM and get back, you need to have ways to trust that, even though you're running in an untrusted environment, so to say.
Just wanted to clarify, in the TPM, in the Microsoft firmware TPM solution, regarding the Linux kernel, which part have been upstreamed and which are still private?
There is nothing upstream. It's an out-of-tree driver.
You need a character device driver which is an upstream.
It still relies on the TPM drivers There are TPM drivers in the Linux kernel.
True, true, but I mean it's using the TPM drivers also, but that's more or less the bookkeeping for the TPM device itself in the kernel. The kernel driver itself, as today the FTPM, is not that big. It's basically just leveraging Opti in this case, the internal API, open a session and then do the invoking of commands.
Okay, so if it's quite small, it should be easily reviewable.
Yeah, yeah,
Or
definitely,
observable.
definitely. I think it's 400 lines, maybe 500 or something. So
Yes,
it's not.
so it had to be upstream. Maybe the bigger part would be the trusted application.
Yeah, the
rather
TA
than-
is quite big. I mean, as you can imagine, the TA itself is built from the TCG reference implementation. So all the source code, so it's the entire TPM. So, and today it also, as I said, includes Wolf SSL. So it's a huge TA we're talking about in this case. And what's been done, I mean, as I said, the implementation runs both on x86 and on ARM. So the differences are in the communication path and how you actually receive the commands on secure side. So in our case with Opti, we have the global platform way of doing things, you know, with open session and invoke commands and so on. So they basically serialize the TPM packet, if I can say so, deserialize it on secure side when we receive it, and then call the TSS reference implementation. So the parts that is kind of touching ARM isn't that big either on secure side, but the whole implementation is quite big. But the changes you will see is like when you need to use the NV index in the TPM, you basically use secure storage in T. So that's where you can see some changes in files in the TCG specification, or the implementation, I would say. Brian?
I'm just wondering, do you know if Microsoft has any interest in supporting and or getting their stuff into Opti in any way?
I don't know. I mean, I plan to reach out to the people. I mean, if we intend to actually work with it, I'm going to ask them, and I say that we plan to do something here. We plan to upstream a driver. Do you want to be the one who is driving that, or should we do it, and so on? But in general, it seems like they have been, I mean, we have seen on GitHub, on Opti, they have been quite active for Microsoft. So the Linux guys.
Quick question: is the three device or the three client, or what do you want to call it, limitation? Is that typically a bottleneck? I mean, does that presumably, if you try to go over three, you end up suspending threads and slowing things down? And also, is that a reason potentially to go to a firmware TPM instead of a hardware implementation?
To be honest, I don't really know if that's considered as a limitation. Stuart might have a comment.
I guess my understanding is that, you know, it's a very small number because, you know, if you're going to go bigger than that, you have to pick some threshold. You can't have an infinite number of keys and so on in the TPM. So what they decided to do was have a very small storage, and all the objects are typically just kept outside the TPM, encrypted as encrypted blobs. And so when I say an application wants to use a key, step one is it loads the key into the TPM, does its operations, unloads the key. And so there's this kind of action of loading the object, using the object, unloading it. And then the resource manager, if say you have 20 applications at the same time doing this, it handles the swapping in and out for you. The applications don't care or know that their keys are being swapped in and out of the TPM behind the scenes by this resource manager. So it's just kind of that's their paradigm, basically, is a very small number of objects. Resource manager handles swapping, kind of like almost like virtual memory in a sense. Yeah, so
But
that's my understanding.
I don't have any information if that actually is a bottleneck. It might be.
Yeah.
The way Stuart describes it, it's a bottleneck. If you have to load and unload a bunch of keys in order to get multiple applications to work, it's going
Right, but that totally depends on the use case also. I mean, if you just do it once in the boot and measure boot and sign a quote from time to time, well, then you won't really see anything. So,
I guess since hardware TPM is I2C, this is the list of your bottlenecks.
all right, I think actually that was the last thing I had. But I mean, if you are interested in this, just reach out to me. I mean, we are heavily interested in knowing who would like to see something like this being used in a T. And as I said, it might be that we either drop it or actually put this on our roadmap in the future. We have 4 more minutes. All right, seems like we're done. Thanks.